And in order to do that, since I'm not here, I'm just recording an Edpuzzle for you to make sure you understand some things. First of all, we've already talked about elastic and inelastic collisions, and I wanted to make sure that we understand both of those have to do with momentum, and that momentum is always conserved when you have a collision. So with an elastic collision, before our definition, we talked about objects, kinetic energy not changing, and momentum staying the same, velocity total staying the same. And I just want to make sure that you understand when you see an elastic collision, then you have objects that bounce off of each other. And so our before and after momentum is going to be the same. And the equations that we're going to use on the before equation and the after equation are exactly the same. So we've got our first object listed as m1v1 and our second object as m2v2. And then in comparison to the after, same thing. Object 1 has the 1s on it. Object 2 has the 2s on it. And then with inelastic collisions, so there's one formula for an inelastic collision, but there's two ways that we're going to look at this. So again, the momentum is conserved with before your collision and after your collision. And there's two ways of looking at this, the same exact equation. All I did was have the left be the start for one and the right be the start for the other. So if you look at my equations, if we have something that sticks together at the end, so let's say that you had two trains that were moving together and then they stuck together at the end, then you would use your initial of two different velocities and two different objects, so m1v1 plus m2v2, with the after collision where they have a velocity that is the same together. So that's why I labeled that one v3. But you could also use the same exact equation, just flip the left and the right in terms of are you starting together with the same velocity or not. And that is still using an inelastic collision equation, but we sometimes call those explosions. So for example, if you were shooting a gun and your bullet and gun were starting with 0 velocity initially, and then the person and slash gun and the bullet were having two different velocities at the end. So all I did was flip-flop my left and my right sides, but it's the exact same equation. And those are known as explosions. And then just a reminder, no matter how you look at momentum and collisions, it is the same total before and after. No matter what you do, your numbers on the left side and the right side of your equation should be exactly the same. And this relates to Newton's third law, which is that every action has a reaction. So if you push something backwards, something else is going to go forwards, is an example of that. So then what we wanted to look at was just doing some practices here on one, just identifying what type of equation we're going to use. So if we're looking at number 1, and we have a 2 kilogram blob of putty moving at 4 meters per second, slams into a 6 kilogram blob of putty, what is the speed of the two stuck together blobs? In order to identify what equation you're going to use, you want to look at whether it talks about something bouncing off of each other or sticking together or starting together. And in this case, it says that two stuck together blobs after colliding. So we see that word stuck together, and we should be thinking of an inelastic equation. So I want you to try to do one on your own. So number 3, a railroad car slams into another railroad car and couples together. What is the combined speed of the railroad cars after collision? And all I want you to do is identify whether it's elastic or inelastic. So because the railroad cars are combined at the end, you're looking at an inelastic equation. Let's look at number 6. Oops. 2 bumper cars are about to collide. Car 1 and its driver, 250 kilograms, is moving east at 2.4 meters per second. Car 2 and its driver, 415 kilograms, is moving west at 7.3 meters per second. After they collide, car 2 is stopped. How fast and in what direction is car 1 moving? All we are going to do real quick is identify whether that is an elastic or inelastic collision. So because car 2 is stopped at the end and you're asked to identify the velocity of car 1, you have an elastic collision. We also want to do some practicing with solving our momentum / velocity and mass equations. So let's look at number 4 and let's solve. It's asking you to solve what direction and speed are they moving. So for this one, I want to make sure that everybody's on the right track here. Because they're going in opposite directions, you need to assign one of the blocks a negative velocity. And usually when you read an equation, you choose the initial block as a positive direction and the second block as a negative direction. Not that that's how you have to do it, but that's just usually the default when you're reading a problem like this. So block 1 would have a positive velocity of 8 meters per second, and block 2 would have a negative velocity of -1 meter per second. When you solve this, you end up getting, I'm gonna type this out for you. You end up getting 1 times 8 plus 2 times -1 and they stick together after a collision. Oops. I'm going to solve for my velocity. So that's my equation that I use here. And I get a velocity of 2 meters per second to the right. And I initially had this 1 kilogram block as a positive. So that's why when I get a velocity of 2, I'm going to say that it's to the right because I initially had my block moving to the right with a positive direction. Let's look at number 6 here. and go ahead and solve that one. So as I'm solving this, I get an answer of negative 1.17 meters per second. And that negative means that I'm going to the left because that's what I initially assigned my second car with, since it was moving west, I assigned west with a negative direction. So if you have any other questions, just make sure that you touch base with me tomorrow, and we'll work on some problems individually with you if you're still struggling with these calculations.